Today we're going to be learning more about solving systems of equations. Last class we learned how to solve them by graphing the two lines to see where they intersect. Today we're going to learn how to solve systems of equations by substituting. We're basically solving them algebraically. So we have two equations and two variables. The way we're going to do this is we're going to solve for one of the variables and then replace that variable in the other equation. It does not matter which variable you solve for first, and sometimes when they give you the set of equations, one of them is already solved for one of those variables. This is one of those things where it definitely is better to watch it happen than to try to explain it in words. So let's look at this set of equations or system of equations. We have y equals x plus 2 and we have y equals 3x. Well, lucky for us, both of these equations are given to us in the form that is solved for one variable. In other words, they both say y equals something, so we already have an isolated variable in both of those equations. So let's just take that first one. That first equation says that y is the same as x plus 2. It literally says y equals x plus 2. So we can take the y in the second equation, and instead of y, we can write x plus 2 because they're the same thing, right? Y equals x plus 2. So I'm going to take this second equation and I'm going to, instead of y, I'm going to write x plus 2, and then I keep the rest of the equation the same. So now I'm going to solve for x. So I can subtract x from this side and from this side to get 2 equals 2x. And then I haven't solved for x yet, but now I can by dividing both sides by 2 to get that x equals 1. So I have part of my answer. Remember, my answer is an ordered pair. I need an x and I need a y. So I've just solved for x. I just found out what x is. Now I can take this x equals 1 and put it into either equation. So I don't know, the first one looks pretty easy. Y equals x plus 2, so I'm going to make it y equals 1 plus 2. Why 1 plus 2? Because x equals 1. And so when I solve this, of course, I just get that y is 3. So the answer is the ordered pair 1, 3. 1 is my x, 3 is my y. All right, let's try some other ones. So for number 1, both of these have a variable that is isolated. So I think I'm going to take my y right here, which is 7 minus x, and I'm going to replace the y in the second equation with that 7 minus x. So let me rewrite that second equation. Instead of y, I'm going to write 7 minus x. So let me highlight what I did. Instead of this y, I replaced it with 7 minus x because the first equation says that y is 7 minus x. So that is an okay move to do. All right, I want my variables on the same side. That's going to give me 2x equals 3 plus 7, which of course we know is 10. I probably should have done that first. Over here, those canceled, right? So now I have a one-step equation. Since x is being multiplied by 2, I'm going to divide both sides by 2, and I get x equals 5. I have part of my answer. Now I'm going to take that x equals 5 and replace it in either one of these equations. It doesn't matter which one, but I think that second one looks a little bit easier. So instead of x, I'm going to put 5. So 5 equals 3 plus y. If you can't get that just by looking at it, you can solve it algebraically to find that y is 2. So my answer is the point 5, 2. 5 is my x, 2 is my y. Let's try the next one. So in this next one, both of the equations are already solved for x. This one's the easiest. In fact, we already have one of parts of our ordered pair. It says literally x is 3. And so I'm going to replace the x in the other equation with 3 to get 3 equals y plus 4. To solve for y, I'll subtract 4 from both sides, and I get that -1 equals y. So there's my ordered pair. That one was pretty easy, actually. All right, moving right along here. Now we see number 3 does not have either equation already solved for a variable. And it doesn't matter which one you do first, but do the easiest one first, right? So in both equations, we do have y with no coefficient, so I definitely want to solve for y first. It looks like that second equation just has fewer numbers going on, so if I wanted to get y by itself, I would add x to both sides. You might be thinking, hey, that's exactly how we found slope-intercept form, and you would be right. That is how you find slope-intercept form. But now I have y isolated, so I'm going to take my y equals x minus 4, and I'm going to replace the y in the first equation with x minus 4. Just make sure that once you solve for a variable that you're replacing it in the other equation, not the one you used to get that. So I'm going to rewrite this first equation, and instead of y, I'm going to write x minus 4. And then I'm just going to solve this. 5x plus x is 6x. Now I have a two-step equation. So I do that by undoing the constant term first. And then undoing the coefficient, I'll divide by 6. So I've got one part of my ordered pair already. The 2 is the x. And then to find the y, let me switch colors. I'm going to take this x equals 2 and replace the x in either one of these equations with 2. I think in this case the first one's easier, even though it seems to have like bigger numbers. That negative in front of the x could throw some of you off, but I'm going to do 5 times 2 instead of 5x because x is 2, plus y equals 8. 10 plus y equals 8. Subtract 10 from both sides, and y is -2. So this is the point 2, -2. This would be, and this is actually, if you graphed those two equations on the coordinate plane and you made lines, they would cross at the point 2, -2. Nice, right? All right, last example, I'm going to take this. If you look at the x, the y, the x, the y, only one of those 4 is already by itself, this one right here. So I'm definitely going to solve for that x. I'll do that by adding 2y to both sides. Then I get x equals 2y plus 4. Then I'm going to take that 2y plus 4 and replace the x with it. Now this one's a little more complicated than the ones we did before, but nothing we can't handle. Let's rewrite that first equation. And instead of x, I'm going to do 2y plus 4. And I'm going to put it in parentheses because there's going to be some distributing happening there. So I just replaced the x with 2y plus 4 because we found out that x equals 2y plus 4. So let's distribute. Half of 2 is 1, so I just get 1y. And then half of 4 is 2, so that wasn't too bad. And then I'm going to get y minus y is just 0y. So I'm left with 2 equals 2. Do you guys remember what happened with equations when the variables disappeared? We learned that if you're left with a true statement, then it has an infinite number of solutions, right? So that is what's happening here as well. If we put both of these in y-intercept form, let's do that. Let's see if I can. So this one right here, let's write in y-intercept form. We would have to subtract 1/2 x from both sides. And then we'd have to divide by -1 because that's like having a coefficient of -1. If we divided everything by -1, we'd have this. And then this guy over here, we wanted to make this one in y-intercept form. We'd have negative 2y, and we would subtract x from both sides, and then we would divide by negative 2, everything by negative 2. And that would give us y equals positive 1/2 x minus 2. Okay, so the reason I'm showing you that is you can see these are the same line, aren't they? And remember when we graphed lines to see where they were going to meet, if they were the same line and they perfectly overlapped, then there was an infinite number of solutions. So you don't even really have to go to the trouble of putting them both in slope-intercept form. Once you get this, once you get that the variables disappear and the statement that's left is true, we know it's all real numbers or infinitely many solutions. Now, if your variables disappear and you're left with a false statement, there's no solution. Those lines would be parallel. All right, guys, thanks for watching.